current electricity using the EPR approach. From the website, B, the problem solving approaches. One of this is to compare resistance of two or more metal wires. Resistance of the metal wire depends on resistivity of the metal, length, and cross-sectional area, which in turn may depend on radius or diameter. Using the EPR approach, first we write down an equation. We indicate which variable is proportional to which variables, and eventually we look at the ratio of the variables. We remove any quantity which is the same for both wires. Okay, let's look at the equation. The resistance of the wire depends on resistivity, length, and is inversely proportional to the area. The area can also be further expressed in terms of radius, if it's a circular cross-sectional area, or in terms of the diameter. Diameter divided by 2 is radius, or another way of writing it is pi d squared over 4. Proportional. The resistance will be proportional to the resistivity times length over area, or in terms of length, resistivity, and radius square, or in terms of diameter, we have a similar expression, rho L over diameter square. Pi, 2, and 4, these are constants, so we ignore them when you write the proportionality. Now the ratio. Okay, if we compare the resistance of two wires, let's say the second wire resistance R2 over the first wire resistance R1, this will be equal to the ratio of the resistivity of wire 2 over resistivity of wire 1 times L2 over L1, and inversely proportional to the area, so we have to write A1 over A2. In terms of radius or diameter, you can write ratio of the resistance equal to ratio of the resistivity, again R rho 2 over rho 1 and length 2 over length 1, times, in terms of radius, will be R1 over R2 because it's an inverse proportion, and not forgetting the square. In terms of the diameter, it will be similar. Consider an example where we have two wires of the same metal and cross-sectional area. In that case, we'll ignore the resistivity of the metal as well as the area or radius or diameter. These are the same for both wires. Therefore, the ratio of the resistance of second wire to that of the first wire will be equal only depends on the ratio of the length of wire 2 over length of wire 1. Consider another example, wires of the same metal only, that means the same row. Now the ratio of the resistance of wire 2 to wire 1 will depend on the ratio of the length as well as inversely proportional to the ratio of the radius R1 over R2 square. Similar for diameter. will be also d1 over d2 bracket square.